Hi guys, so I thought that today we could do maybe a little review on oxidation and reduction. I thought this topic was pretty easy to be honest, but I know we sometimes tend to forget some stuff, especially maybe we understand it now, but before exam 3, maybe we forget about it. So I thought it would be quite nice to have a video now that we have it fresh in our minds to maybe have it just as a reminder if we need to go back into it and look what oxidation and reduction is about. So then overall oxidation and reduction states. So oxidation is an increase in the oxidation state of a carbon, as you can see here. And normally like we will go from -4 to +4. So it's between that range. While reduction is a decrease in the oxidation state of a carbon atom. So instead, we'll go from +4 to -4. For example, if we convert methanol into formaldehyde, we would say that methanol was oxidized because we're going from -2 to 0. Another example would be if we converted formic acid into methanol, and formic acid has a charge or has an oxidation state of +2, while methanol has an oxidation state of -2. So it would say that formic acid is being reduced. So we're going from +2 to -2, which will mean that we're being reduced. So things to know. So a carbon atom with 4 bonds will, as we know, since it's just a regular carbon atom, like by 4 bonds it can mean something like this, it just has a total of 4 bonds. So that means that it's just in its regular state and it doesn't have any lone pairs, not anything. It doesn't lack a bond, so it's just in its regular state, so it doesn't have any formal charges. But its oxidation state can range from -4 to +4, just like as we saw in here. So then the most oxidized state, we can say that it's going to be carbon dioxide, while the most reduced state, it will be methane. So how to calculate oxidation state? So all of this ties back into electronegativity. So when dealing with electronegativity, we have these things called partial charges. We have a partial positive and a partial negative charge, which are represented by the Greek symbol delta. And the most similar thing to delta, I had this, so. But they look kind of similar, to be honest. So technically, the most electronegative, I know this can be confusing, but the most electronegative will carry a partial negative charge, while the least electronegative will carry a positive partial charge. As you can see, we all know that oxygen is more electronegative than carbon. Therefore, oxygen carries a negative charge, while carbon is less electronegative than oxygen. Therefore, it's going to carry a positive charge. So technically, when we're calculating like oxidation state, we focus on each bond individually, or in each separate group of bonds individually. So so we look at two different things, like right now we're just looking at a separate bond between carbon and oxygen, and we know that oxygen is going to carry that negative charge and then the carbon is going to carry that positive charge. So I just decided to put a little like the negative charge in there, just in case if you wanted to look back into it, so you know where to find it. So then, yeah, I mean, and when you're doing a test, technically, you can also do this. So then electronegativity goes this way, it goes up. So we know that our like periodic table normally looks like this, I would say so. So then on the test you can technically do this, and you already know that electronegative is gonna go that way. So now that we know that, we can explain this chart. So we can technically kind of like calculate already. So then we know that, so like I said, we're gonna compare each bond individually. So for example, between carbon and hydrogen, we know that carbon is the most electronegative, therefore that one's gonna carry a negative charge, and hydrogen's gonna carry that positive charge, since hydrogen is least electronegative than carbon, and everything else is the same. We still have that carbon hydrogen relationship, so still negative positive, negative positive, negative positive. And technically we just focus, since we're calculating, like we said, is that oxidation state is the oxidation state of a carbon atom. Therefore, when we're counting, we're just gonna count the charges that are around that carbon atom. So then if you count, we have -1, -1, -1, -1. If we add all of them up, we have -4. Okay, so for example, we have in here, we have 3 carbon hydrogen bonds, and we know that carbon hydrogen, we normally have carbon being the more electronegative, therefore it's going to carry the negative charge, and hydrogen is going to carry that positive charge. Oops. Okay, so we don't get confused. We have 1, 2, 3 so far. So we're gonna do a -1, -1, -1. And then if we look at a carbon oxygen right here, we said before that oxygen is more electronegative than carbon. Therefore, oxygen is the one carrying a negative charge, and carbon is the one carrying a positive charge. And since it's just a single bond, we just count it as +1. So then -1, -1, -1, we have a total of -3. -3 plus 1 is gonna equal -2. Okay, so formaldehyde. So then, for example, do you guys remember when we did our priority groups? We kinda counted, like, double bonds, we counted as 2 bonds. So I would say you can technically do that in this case as well, because when solving these problems, what I've been doing is this. Like, if it's hard for you to visually see this, I would normally just like, oh, this is just constant 2 times. So then I would just draw it like that, so it's more visually easy for me. And then, for example, like we said before, we already know carbon oxygen. Oxygen is more electronegative, therefore it's gonna carry a negative charge, and carbon's gonna carry a positive charge. And in a carbon hydrogen bond, carbon is more electronegative and it's gonna carry a negative charge, while hydrogen is less electronegative than a carbon and it's gonna carry a positive charge. So then we have negative, positive, negative, positive, or we can also put it in here, negative, positive, negative, positive. And then in here we have 2 bonds to oxygen. Therefore, we saw our carbon is gonna carry a positive charge. We have positive, negative, then we have another positive, negative, and if we count, we have 1, 2. You have 2, so we have +1, +1, and then we have -1, -1, and then +1 -1 +1 -1 will get 0. So then depending on the number of bonds, so then for example in here we're counting just one carbon hydrogen, so it's just -1. In here one carbon hydrogen, -1, and in here we're doing 1, so that's why it's +1, and here we're doing another one, it's +1. Okay, so then here we have, that's why it says like it's more visually easy, just to like, that it's gonna count as 2, so you don't stress yourself out. You can just do that. So then again, we already know carbon, oxygen, carbon, hydrogen. Carbon's gonna carry a positive, oxygen's gonna carry a negative. Carbon is the carbon, hydrogen. Carbon is more electronegative, it's gonna carry a negative. Hydrogen is less electronegative and it's gonna carry a positive. So then in here we have our central carbon, as we know. So then carbon, hydrogen. Carbon's gonna carry the negative charge. Carbon, oxygen. Carbon's gonna carry that positive charge. Carbon, oxygen. Carbon's gonna carry that positive charge, and then carbon, oxygen. Carbon's gonna carry that positive charge. Then we have 1, 2, 3. So then we have +1, +1, +1, and then we have a -1 right there. So then we have a +2. And then we have carbon, oxygen, 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 oxygen. And we already know that carbon, oxygen, we know that carbon's gonna carry that positive charge since it's less electronegative than oxygen. And then oxygen's gonna carry a negative charge since it's most electronegative than carbon. Therefore, carbon's gonna be positive, this one's negative, this one's positive, this one's negative, positive, negative, positive, negative. We have 4 positive charges surrounding our carbon. So then we have +1, +1, +1, +1, which is gonna equal a +4. See, it's way easier to explain it now, right? That we know how everything works. There's also some patterns that you can technically notice. So then, for example, let's play carbon-carbon bonds. So then carbon-carbon bonds, like we said, this is about electronegative, and then a carbon is not more electronegative than another carbon. Therefore, they're gonna count as 0. They don't count as +1, -1, nothing. Even carbon double bonds, nothing. Carbon triple bonds, nothing. Carbon, hydrogen, we can explain that already. Like we said, carbon is more electronegative. There's gonna carry a negative charge, where hydrogen is less electronegative, so it's gonna carry a positive charge. Carbon, so then carbon, oxygen, single bond. So then oxygen is more electronegative, therefore it's gonna carry a negative charge, and then carbon is less electronegative, so it's gonna carry a positive charge. That's why we have a +1 in here, and that's why we have a -1 in here. So then carbon double bond. So then we have in here carbon, 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 and then oxygen, oxygen, which equals the same thing. So then we know that carbon, here we have our positive, and then we have our negative. We have carbon, we have positive, negative, positive, negative, and then we know that carbons, they don't really count, so then this one is nothing, nothing. So then we have a +2. And then carbon, chlorine, or anything that's more electronegative, anything that's more electronegative than carbon, it's gonna count as +1. Of course, it has to be a single bond, so take in account that it's gonna be a single bond. But then anything, if it's more electronegative, then it's gonna carry that negative charge, and then carbon's gonna carry that positive charge. And of course, if there was a situation where it was bonded to something less electronegative, like per se, if we look at our chart, then let's say carbon and a lithium. Let's say we have lithium, for example. Okay, so example, carbon lithium. Then that means that this one, it will be less electronegative, therefore it's gonna carry a positive charge, and then carbon will be more electronegative, therefore it's gonna carry a negative charge, and it's gonna count as -1. And of course it has to be single bonded as well. So single bonds count as 1, double bonds count as 2, triple bonds count as 3. Okay, so now we can technically explain this chart that Alexis shown in class. So let's see. So it's the same concept like I told you. So then carbon hydrogens, we know that carbon's gonna be more electronegative. That's why, oops. Maybe I'll change the color right there. Okay, so then we know that carbon, so then carbon hydrogen. So then we said that carbon hydrogen bonds, we know that carbon's gonna carry a negative charge because it's more electronegative than a hydrogen. And then hydrogen is less electronegative than a carbon, therefore it's gonna carry a positive. And then we just have carbon hydrogen bonds, so then carbon's gonna carry those negative charges, and we only count the charges that are surrounding the carbon, so then that's why we have 4 negative ones, and then that's why we have -4. We said that carbon bonds, we can't, so then the next one, we said that carbon bonds, we cannot technically say that a carbon is more electronegative than a carbon, therefore we count it as 0, so this one is kind of like gone. We don't really think about it. And then again, we just go to the same concept, carbon hydrogen, that hydrogen's gonna carry that positive charge, the carbon's gonna carry that negative charge. And we only have 3 bonds, carbon hydrogens, therefore it's gonna be -3. We said that double bonds to something's gonna count 2 times, but this time it's a carbon-carbon, therefore carbon-carbon, we don't care. We don't care about it, so then it's gonna count as 0 technically. And then we have carbon hydrogens, we have our same relationship again, carbon negative, hydrogen positive. We have 2 negative charges surrounding that carbon, therefore we have -2. Then in here we have a carbon-carbon, we don't care about it. Carbon hydrogen, we already know carbon has a negative because it's more electronegative than a hydrogen. And then hydrogen has a positive because it's less electronegative than a carbon. And then we have our carbon-oxygen relationship, in which oxygen is more electronegative, therefore it's gonna carry that negative charge, and then carbon is less electronegative, therefore it's gonna carry that positive charge. So then we have 2 carbon hydrogens, we have -2. And then we have 1 carbon-oxygen relationship, therefore it's gonna be +1, and that's why we have -1. And then we said carbon-carbons, they don't really matter That's why our oxidation state 0. So then this is triple bonded, so it's gonna count 3 times, but since it's carbon-carbon, it's gonna just equal 0. So then again, this one is carbon oxygen, so then carbon-carbon, we don't care. Carbon-oxygen double bond, but we said that if you want it, you can always do this, carbon-carbon hydrogen, and then just split them up. If it's easier for you visually, just split them up and it's gonna be the same. So then in here you have a carbon oxygen, carbon carries a positive, carbon hydrogen, carbon carries a negative. So then therefore we have positive, positive, negative. We have +2 -1, we have a +1. And the same goes in here. We have a, let's see, we have carbon, carbon, so then we don't care about this 2, but we do have this relationship. We have, and we said again, carbon, oxygen, carbon is least electronegative, therefore it's going to carry a positive. Oxygen is more electronegative and it's going to carry a negative, so then negative, positive, negative, positive. We have 2 positive charges surrounded that carbon, therefore we have +1 +1 is going to equal +2. Let's see, carbon, carbon, we don't care about it. We have, but looking at this one, we have carbon, oxygen, 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 carbon, we don't care about this one. Carbon, oxygen, we have positive, 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 therefore we have +3. And then carbon, chlorine, we just already established that anything that's more electronegative than a carbon, it's gonna carry that negative charge, while chlorine is gonna carry a positive charge. Therefore we have 4 carbon, chlorine, so then that's why we have +1 +1 +1 +1, and then that would equal +4. Okay, so now we can practice a little bit. So then just a reminder, oxidation is like when we're going from -4 to +4. Reduction is when we go the opposite way, so then from +4 to -4, and then neither, it will be just like if we were going from +3 to +3, so there's no change overall. So then in each of the following transformations, identify whether the starting material has been oxidized, reduced, or neither. Okay, so let me get a more powerful color for you guys. Okay, so then we have this carbon, carbon, we have this carbon, 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 and then we have a double bond oxygen. So like I said, if it's more visually easy for you to see it like this, then just do it, just draw it. It only takes you like an extra 10 seconds. Even though my carbons look like oxygens. So then, let's see. So then we have carbon, carbon, and then we have carbon, oxygen. So then carbon, carbon, we said we cannot technically identify it, so this one counts at 0. So then we can eliminate those 2. And then we have carbon, oxygen. Oxygen is more electronegative, therefore it's going to be negative. While carbon is less electronegative than an oxygen, therefore it's going to be positive. Just remember, we count each bond individually, or since we separate the single bonds, but if you have a double bond, you can just multiply by 2. If you have a triple bond, you can multiply by 3. So then in here, we're looking at this one, and then we have carbon's gonna carry their positive charge, positive, negative, positive, negative. And remember, we just care about the charges that are surrounding that carbon. Therefore, we have a positive 2. And then in here we have carbon, 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 chlorine. So then we know that carbon, carbon, just count as 0 like we said. And then carbon, chlorine. So then we know chlorine is more electronegative than a carbon, therefore it's going to be negative, while carbon is going to be positive. So then we have a negative chlorine, positive carbon, negative chlorine, positive carbon. And then we said that carbon, carbons, they don't really count. So then therefore we just have a plus 2. So then if we go from plus 2 to plus 2, I don't think nothing changed, right? So then it will be neither. It wasn't either. It wasn't oxidized or reduced. So then we can look at the next one. Let's look at this central carbon right here. And let's remember to put all of our bonds. And here we can only see 3 bonds. So then we need to add our hydrogen bond right there. So then we have carbon, 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 carbon. We don't care. We do have a carbon hydrogen and a carbon oxygen. So then in here we also have a carbon hydrogen. Carbon hydrogen, we know that carbon is going to be more electronegative, therefore it's going to carry a negative. And then the hydrogen is less electronegative, therefore it's going to carry a positive. So then carbon's going to carry a negative, hydrogen's going to carry a positive. Well, on the other hand, carbon carries a positive and oxygen carries a negative. And then remember, we don't care about carbon-carbon bonds because they equal 0 in any form. So then I'm just going to do a plus 1, minus 1, which is going to give me a 0. Okay, so then we can look at the next one. We have 1, 2, 3, 4, so then we don't have an extra hydrogen in there. Remember, we can always translate this into something like this, so it's more easily visually for you guys. So then we already said carbon, carbon, we don't care, so we're just gonna focus on that carbon, oxygen. Carbon, oxygen, again, carbon carries a positive, oxygen carries a negative, positive, negative. We have 2 positive charges surrounding that carbon, therefore we have a plus 1, plus 1, we have plus 2. So if we went from 0 to plus 2, I think we got oxidized. Okay, so now we can look at the next one. So then we have carbon, 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 carbon. My central carbon has 4 bonds, therefore it doesn't have a hidden hydrogen in there. So then we have carbon, carbon. Remember, we can always translate it. We have oxygen, oxygen, carbon, 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 carbon. We don't care about carbon-carbon bonds, so then carbon, oxygen. Remember, carbon is less electronegative than an oxygen, therefore there's a positive, negative. You have a positive, negative. We have only 2 positive ones around that carbon, so then we just have plus 2. Oops. Okay, I got scared for a second. Oops. Okay, we didn't lose that much. Okay, so then we have a plus 1 is gonna equal plus 2. And then in here we have a carbon, oxygen, 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 carbon. So then we have plus, minus, plus, minus, plus, minus, and then carbon, carbon, we don't care. Therefore, we just have positive, positive, positive. So then we have plus 1, plus 1, plus 1. And then we have plus 3. So then we went from plus 2 to plus 3. That means that we were oxidized. Okay, so I think you can try it on your own now. Okay, let's see if you got these questions right. I believe you did. Let's see. We can do this one first. So then we have our focus carbon. Our focus carbon, we can see that it has 4 bonds, so then we don't need to add an extra hydrogen. The next step, to make it easier, we're gonna convert it. Okay, so we can just start a little chart in here. So then we have a carbon, oxygen. We know that carbon's gonna carry a negative, let's say, no, carbon's gonna carry a positive charge because it's less electronegative than an oxygen. And then oxygen's gonna carry a negative charge because it's more electronegative than a carbon. Then we have our carbon-carbon bond, which we technically cannot calculate electronegative of it. So then it's gonna equal 0. And then we have our carbon hydrogens. Carbon hydrogen, carbon is more electronegative than a hydrogen, therefore it's gonna carry a negative. While hydrogen is less electronegative, therefore it's gonna carry a positive. Now that we know that, we can assign charges. Let me make this bigger. So then we have carbon, oxygen, oxygen, carbon, hydrogen. Okay, so carbon, oxygen. Carbon, oxygen, carbon carries that positive charge, positive. Oxygen carries that negative charge. Carbon, hydrogen, carbon is going to carry that negative charge and hydrogen is going to carry that positive. And carbon, carbon, we don't care about it. So then what's surrounding that carbon? We have positive 1, and negative 1, which it will give us a oxidation state of +1. And then we can look at the next one. We have a total of 4 bonds, therefore we don't have any hidden hydrogens. We can translate this into carbon, oxygen, 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 carbon. We don't care about carbon-carbon bonds, so then carbon, oxygen, we know that carbon's gonna carry that positive charge then, and then oxygen's gonna carry that negative charge, and that's due to electronegativity. And then we have this one's in here, we have +1, +1, +1. Therefore we have +3. So then if we went from +1 to +3, we were oxidized. Okay, so then we can look at this one in here. So then we have our carbon, our central carbon. We have carbon, oxygen, 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 carbon. So then we know carbon, oxygen, carbon's gonna carry that positive, oxygen's gonna carry that negative, positive, negative, positive, negative. If we look into it, the surrounding carbons, we have +1, +1, +1. It's gonna equal +3. And just as a reminder, we don't care about carbon-carbon bonds. Okay, so then in here, our central carbon, we can only see 2 bonds, therefore we have 2 hidden hydrogens. So then carbon, oxygen, we know that carbon's gonna carry that positive, carbon's gonna carry that positive, oxygen's gonna carry that negative. Carbon, hydrogen, Instead, hydrogen is less electronegative than carbon, therefore it's gonna carry that positive, and then carbon's gonna carry a negative. Let's see. So then we go from carbon oxygen, we have positive, carbon hydrogen, we have negative. We have -1, +1, we have -2, +1, we have -1. Which would technically mean we were reduced. Okay, oh my goodness. So then I went quiet for a second because the key for the book is kind of confusing. So then instead of like showing you the actual like key problems, it just gives you like a big paragraph. So I didn't organize it by letter. So then I got scared because I was reading the whole paragraph and I was like, did I get it right or wrong? But we did get it right. Okay, so now we can finally solve this one. So then we can translate this one. Okay, carbon, oxygen, chlorine, carbon, and then we have for carbon, oxygen, carbon. Okay, I mean, if you were to look at it, you would notice that we will have the same oxidation state, but just for practice sake. So carbon, we have a new one. We have carbon chlorine now. And we know that chlorine is more electronegative, therefore it's going to carry a negative, and our carbon's going to carry a positive. So carbons, we don't care. Carbon chlorine, carbon has a positive, chlorine has a negative. Carbon oxygen, carbon has a positive, oxygen has a negative, and then carbon has a positive, oxygen has a negative. So then we have positive, we have a +3. Oops, did that carbon erase? Okay. And now again, we have just carbon, oxygen. We know that carbon is going to carry a positive, oxygen negative, positive, negative, positive, negative. We don't care about carbons. Positive, we have a +3. So we went from +3 to +3. That means that we were neither oxidized or reduced. Okay, perfect. So hopefully this video was helpful. Maybe just for like a review again on what we went over on Friday, or maybe just as a review before exam 3. But thank you for taking your time to review with me, and I hope you have a wonderful day.